This lesson will show how to use Desmos.com to graph a binomial distribution and determine probability. Let's begin by discussing the characteristics of a binomial experiment. Number one, there are a fixed number of trials. The trials are the repeated experiment. The variable n denotes the number of trials. Number two, there are only two possible outcomes for each trial, success or failure. The variable p denotes the probability of a success on one trial, and q often denotes the probability of a failure on one trial, and therefore p plus q must equal 1 or 100%. Number three, the n trials are independent and are repeated using identical conditions. Because the n trials are independent, the outcome of one trial does not affect the outcome of another trial. And then finally, number four, the random variable x equals the number of successes in n independent trials. Let's look at an example. A fair coin is tossed 50 times. Because the coin is fair, there's a 50% chance or 1/2 chance of getting a head and a 50% chance or 1/2 chance of getting a tail. We're asked to determine each probability and give the answer as a decimal to 3 decimal places and a percent to 1 decimal place. Let's begin by graphing the binomial distribution using Desmos. To begin, we go to Desmos.com and click Graphing Calculator. In cell 1, we can either type in binomial dist, or from the Desmos keypad, click Functions, click Distribution, and click Binomial dist. Notice Desmos is prompting us to now enter the number of trials followed by the success probability. So the coin is tossed 50 times, and therefore there are 50 trials, comma. The coin is fair, and therefore there's a 50% chance of getting a head, and therefore the success probability is 50%, 0.5 or 1/2. I will enter 0.5. Let's close the Desmos keypad. Right now we do not have a good window to view the graph. To quickly adjust the window, we click the Zoom Fit button below the red circle, which is the magnifying glass with a plus. And now we have a nice graph of the binomial distribution. If we want to, we can change the color by clicking and holding on the red circle and selecting a different color. I'm going to go ahead and select blue. To close this menu, click outside the menu. Now from here, if we want to, we can click on any of the points on the graph. It will give us the corresponding probability for getting that many heads out of the 50 trials. So for example here, this ordered pair tells us the probability of getting 21 heads is approximately 0.060 or 6%. And we can click on any of the points that we want. Let's go ahead and clear these. But our first probability is the probability of getting 30 or more heads out of the 50 trials. So we're going to go ahead and click on this box here that says Find Cumulative Probability. And because we want the probability of 30 or more heads, this would be the same as getting from 30 to 50 heads. So we'll enter 30 for the min, tab, 50 for the max, and the probability appears below. The probability of getting 30 or more heads is approximately 0.101 or 10.1%. If we look at the graph for a moment, notice how the closed or solid points represent all of the successful outcomes of getting 30, 31, 32, 33, and so on, all the way out to 50 heads from the 50 trials. Let's go ahead and record this and find our second probability. So as a decimal, we had approximately 0.101, which is equal to 10.1%. Next, we want the probability of 28 or less heads. 28 or less would be from 0 to 28. So we change the min to 0, tab, max to 28. We want 28, not 18. And the probability appears below 3 decimal places. We have approximately 0.839 or 83.9%. Again, looking at the graph, notice how the closed points and the vertical line segments represent the successes of getting 28, 27, 26, 25, and so on, all the way down to 0 heads. So if we were to find all these individual probabilities and then find the sum of the probabilities, we know it would be this value here of approximately 0.839. Again, let's go ahead and record this probability. Approximately 0.839 which is equal to 83.9%. Next, we want the probability of getting from 25 to 35 heads, including 25 and including 35. So now the min is 25, the max is 35, and the probability of getting from 25 to 35 heads out of 50 trials is approximately 0.555 or 55.5%. And for number 4, we want the probability of getting exactly 30 heads. To find this probability, we can set both the min and max to 30, which gives us approximately 0.042 or 4.2%. Also notice how if we click on the closed point on the graph, we do get the same result. And 0.042 is equal to 4.2%. I hope you found this helpful.